Welcome to Unit 6, Geometric Vectors, Lesson 3, Multiplying a Vector by a Scalar. Some key concepts: when you multiply a vector by a scalar, the magnitude is multiplied by the scalar of the vector, and the vectors are parallel. So if you multiply any vector by a scalar, you will get a parallel vector. That direction remains unchanged if the scalar is positive. So for instance, here's my vector. Let's say I multiply this vector by a scalar of 2. I would get the magnitude being multiplied by 2. So you can see that my arrow is about twice as long as this one, and they're still going in the same direction. Or becomes opposite if the scalar is negative. So again, here's my vector. Let's say I multiply it by a scalar of -3. I can see that the length of this line is 3 times the length of that line, and you can see it's going in the opposite direction. For any vector, u and v, and scalars k and m, such that they're real numbers, we know that if I do the scalar k times u plus v, just like grade 9 math, we can distribute that to both. So it's really scalar k times vector u plus scalar k times vector v. Same thing here. If I've got scalar k times scalar m times vector u, that's the same as k times m, where they're both scalars, times the vector u. And we also have 1 times any vector, of course, is itself, the identity property. Also, linear combinations. Linear combination of vectors can be formed by adding scalar multiples of 2 or more vectors. We're going to see that further on in this lesson, also in this unit. Also, the fourth property, vectors u and v are collinear. This is a very important word, collinear, if they lie on a straight line. So if you can rearrange the vectors, and again, you can move vectors wherever you want, but if you rearrange them and they create a straight line, then they're called collinear. The vectors are also scalar multiples of each other, which means that they are parallel. And you're going to see that these three words, collinear, scalar multiples, and parallel, are really synonymous. So if you see collinear, that means they're scalar multiples. If you see scalar multiples, that means they're collinear. If you see parallel, that means they're scalar multiples, and vice versa. So any of these three words can be interchanged for the other ones, and they really mean the same thing. The following statements are true about non-zero collinear vectors. U and v are scalars of each other, such that u is equal to some scalar k times v. Again, there's that key word there, scalar multiples. U and v are collinear. That means you can rearrange them and then they make a nice straight line like this. And u and v are also parallel. That means they're running in the same direction. Or opposite direction. But again, the big key here is collinear means straight line, means scalar multiple. Which means parallel. If you see this word, that means this word, which means this word. And that's C. So these three things are synonymous. You can interchange one with the other and it will mean the same thing. Collinear, scalar multiples, and parallel all mean the same thing. All right, here is my first example down here. It says, for which vectors are scalar multiples? Again, scalar multiples, that means either collinear or parallel. Here we're going to look for parallel of vector v. So here's vector v. So which ones go in the same or opposite direction as vector v? Well, I can see A does, going in the same direction. I can see C does, same direction. D here is as well, but going the opposite direction. And finally F, also going in the opposite direction. So A, C, D, and F, because you can all see that they're parallel. it says here, find the scalar k for each scalar multiple in part A. So for this, I'm going to need a ruler. So I'm going to pull out my ruler. And so I'm going to write each of these vectors in terms of vector v. So vector v is equal to. So here's my vector v. I'm going to take my ruler and I'm going to measure the length of it by vector. So here we go. So vector v is about 2 centimeters. Let's start with vector a. So vector a is 6 centimeters. So that means I would have to take a third of vector a to get my vector v. So v is equal to 1/3 of vector a. Let's continue. So let's do the next one, which is c. I can see that, oh, c is also just 2 centimeters. Same as vector v, so vector v is just equal to vector c, so I can interchange them if I wanted to, if I had a vector expression. All right, let's do the next one, d. So here's vector d. I can see vector d is half the magnitude of vector v, so I'm going to multiply vector v by 2. But wait, Mr. Wills, it's going the opposite direction. Yes, it is. So I'm going to put a negative sign because it's going in the opposite direction. Again, that negative sign means it's going the opposite direction. And then finally, vector f. So vector f, if I measure it, it's about 4 centimeters. Vector v is 2 centimeters. So vector f, if I want to get it to the magnitude of vector v, I'm going to multiply by 1/2. But wait, Mr. Wills is going the opposite direction again, so yes, I will put that negative sign up front. So I've written each of the 3 vectors in terms of vector v with a scalar in front and using a ruler to measure the length of each. And again, this and this both have negatives because they're going in the opposite direction. Very important. All right, explain those vectors that are not scalar multiples of v. Explain why they are not. Simply, they are not e and b, or b, I'll go alphabetical, b and e, because they are not parallel. And again, going back to this, if they're not parallel, they are not scalar multiples. If they're not scalar multiples, they're not collinear. Using that big, using again those 3 words in synonymously. All right, the last example I will do for this video is example 2. You can find example 3 and 4 and 5 done in separate videos. So example 2, scalar multiples. Consider vector u with magnitude of 100 kilometers an hour, and again notice the magnitude bars beside, or the absolute value bars beside it, at a quadrant bearing of north 40 degrees east. So 40 degrees off the north in the northeast quadrant. So there is my vector u. It says, draw a vector to represent each scalar multiplication and describe in words the resultant vector. So here we go, 3u. So again, I'm going to pull out my ruler. If I want to write vector 3u, I'm going to measure it. This is not going to be exact, but I'm going to go pretty close. So there we go, I can measure vector u, and vector u looks like in my diagram here, a little about 2, say 2, I'm going to go 2 centimeters. I know it's a bit longer than that, but just for the sake of drawing this. So about 2 centimeters, so I'm going to draw my vector 3u. It's going to have 3 times the length of that, so I'm going to draw a vector that is about 6 centimeters in the same direction because it's positive. So here we go, I'm going to draw one at 6 centimeters. There we go, stop. Draw the tip, signifying the tip, there we go. And this vector here is 3u. Now it says here, describe in words the resultant vector. So that's my resultant vector, so I know my magnitude of 3u. So I'm not really going to use words, I'm basically going to use some symbols here. Is going to be, the magnitude is going to be 3 times 100 kilometers an hour, so it's really going to be 300 kilometers per hour. Direction. The direction will be the same as before. North, 40 degrees east. Next one is 0.5u. So again, I said my original vector u is about 2 centimeters, so I'm going to draw it as the same direction because it's positive, but I'm going to draw it about half that, so about 1 centimeter. So there it is right there. There's the arrow. And so let's again, this guy right here, that is 0.5u. The magnitude of 0.5u is equal to, well, half of 100 kilometers, so it's going to be 50 kilometers per hour. And same direction, my direction will be north. Brain is moving faster than my hand. North 40 degrees east. There we go. The last one, negative 2u. So negative 2u, so that means I'm going the opposite direction. So again, I know my vector u originally is 2 centimeters, so it's going to be double that, so it's going to be 4 centimeters, but in the opposite direction. So I'm going to measure it out here. So there's my 4 centimeters. And notice how I am still a parallel vector, but going the opposite direction. So I started here, went this way, but my other one's going to go the opposite way, so I'm going to go down here. Draw it to there. So this guy here, that would be negative 2u. The magnitude of negative 2u, well, it's just going to be double the 100 kilometers an hour, so it's going to be 200 kilometers per hour. Now direction, we can use opposite angles here. Since this angle here is 40, I know this angle here is also 40. Going back to my grade 9 geometry days. So my direction will be south 40 degrees west, because I'm in the southwest quadrant, always off the vertical axis. There we go. So again, my examples 3, 4, and 5 are going to be on different videos, but that is the end of page 11.